Okay, so let's continue with problem 311. Two electrically charged pit balls, each having a mass of 0.2 grams, are suspended from light threads of equal length. Determine the resultant horizontal force of repulsion, F, acting on each ball if the measured distance between them is r equal to 200 millimeters. Okay, so we have two charged spheres, as you see on the screen, and they repel each other with the force of F, as you see, and in fact the distance between them is 200 millimeters. There is a very light rope or string like object which holds these spheres, and therefore there is a hinge on the wall and they are suspended to the wall. The distance between the hinges are 50 millimeters. The length of massless rods or strings are 150 millimeters. Okay, so let's draw the free body diagram of the object. First, this is the first thing that we need to do. So this is our object, so charged spheres, and let's define our coordinate system, and let's say that horizontal axis is the x-axis and the vertical axis is the y-axis. Certainly we just consider one of the spheres, it's more than enough. So it is repelled by the other one with a force of F. It has a mass, therefore it has a weight W. This is force acting on it, and there is a tension in the string due to the weight and repulsive force F. So this is the tension, and as a result the string makes an angle of theta. Okay, so let's write the forces acting on the sphere, acting on our particle first. Well, we have the weight first. So weight is equal to minus mass times g. G is the gravitational acceleration multiplied by j vector because it's in the negative y direction. Then we have the repulsive force. F is positive. We don't know the magnitude of it yet. It is F multiplied by I vector. It's in the positive x direction. And we have the tension in the rod. So it's T. And tension in the rod is negative in x direction because it will pull this sphere in this direction. So it is minus cosine theta I plus sine theta j. So barely this is the unit vector along the string. Okay, now we are given the dimensions, and let's calculate the theta. Cosine theta is equal to the let me show you. So there exists a triangle, right? And since r is equal to 200 millimeters and this is 50 millimeters, this distance has to be 200 minus 50 divided by 2. Therefore this distance is 75 millimeters and hypotenuse is 150 millimeters. As a result, we have the cosine theta. So 75 divided by 150. which makes 1 over 2, and sine theta therefore square root of 3 divided by 2, and theta is equal to 30 degrees. From here we can easily say that. Okay, now we have found the angle that the string or massless rod or wire makes. Now some of the forces acting on the particle, on the charge sphere, has to be equal to 0. Therefore, when we look at the forces in the x direction, we have only the force, repulsive force, coming from the other charged sphere, and t multiplied by cosine theta, and they have to balance each other. As a result, the force acting on the object in x direction has to be equal to f minus t cosine theta I vector. Now in y direction I have t sine theta minus mg. So basically I sum up the all the forces, sum of the forces, and it has to be equal to 0. Now this gives us two equations, because both the coefficients of the I vector and j vector have to be 0. Therefore, from the y direction, I have t sin theta minus mg has to be equal to 0. So this is this equation. Okay. From here, I know the mass of the object, I know the gravitational acceleration g, I know the angle, so I know sine theta, so I can calculate the the tension in the rod. Okay, now let's go to the equilibrium in x direction. It is f minus t cosine theta, and it has to be equal to 0. So f is equal to t multiplied by cosine theta. So remember that we have calculated the tension in the rod, and it was mg divided by sine theta. As a result, force, repulsive force, is equal to mg cosine theta sine theta, or mg divided by tangent theta. Now the mass of the object in kilograms, we use SI units, therefore we use kilogram for the mass, meter for the length, and second for the time, always. So the mass of the object is 2 multiplied by 10 to the power minus 4 kilograms. Gravitational acceleration is 9.81 meter per second square, and tangent 30, tangent theta, is equal to square root of 3. From here we can find the force, repulsive force, as 1.13 10 to the power minus 3 newtons. N is for newtons.